So this is my demo video for project 1. Now to build the project, you can either build it via Eclipse by loading the project in and building either the individual programs or the entire project. And you can do the same here in console, but I'm going to build actually the entire program, which builds both. So the entire project which builds both programs. And to run it, you just use either of these commands. The only prerequisite you'll need is Java 17. Gradle's not needed because I have the wrapper, and JavaFX 17 is also not needed because I'm loading it via Gradle. So I'm just going to show one example each, and then I'm going to go through how it works. For the wave viewer, for question 1, once it loads, we don't load the file select screen for both initially because I wanted to make sure that in case, let's say here, I don't select the file, it will show no file selected instead of erroring out or showing it in the console. If we load just one of them cartoon to top, we see the left waveform, and the bottom we see the right, and we see the sample rate and total samples on the bottom. How I'm getting this to work loaded and drawn is I'm loading the file in as an audio input stream, getting the format, and getting the number of bytes, figuring out, and then for each byte, so each pair of bytes corresponds to the lower and higher bit, and every even pair, so the first and second, the first pair which is corresponds to the left channel, and the second pair corresponds to the right channel. And I'm getting the bits and storing them in an array with nested array with left and right channels. And afterwards, then I'm going to draw these and also draw these waveforms here using stroke line from JavaFX. And then for the other details, such as sample rate and sample count, I'm calculating these based on the details we got from the file and displaying them as labels on the bottom of the screen. And then for the second program, if we run this here, PNG viewer, same thing, the start screen's the same. Let's just load the balloons. You can see here on the left is the original image, the right is the histograms. If you hit the next button, you get to see the original and vivid image. Now the window might expand across over the screen because I'm dynamically, because the scenes are two different sizes, and the initial scene is usually centered, so because the second scene is longer, a lot or wider, it maybe expands across the screen. So just move it over to see the rest of the controls. So we have the original image again drawn on the left, the third image on the right, and if you hit next, you go back to the beginning, and then the exit button or the top can be used to exit. Now, how that works is I'm loading it in as a buffered image, getting the RGB values, and then also using those RGB values to grab the histogram here by comparing how frequently each RGB value from 0 to 255 is used and incrementing it each time it runs into one of those values. So the histogram gets drawn that way afterwards. And in the dithering, all I'm doing is I'm using a 8x8 dithering map, which I'm normalizing down here to 255, between 0 and 255. And after adding 1 to the dithering map values, just so that they're in range. And also, so when comparing, it's actually so 0 actually becomes 0 and 255 becomes 255. And how this works is I'm doing this, tying this to each channel on the RGB, and then I'm drawing all the images using the pixel writer in JavaFX, and the histograms using the line drawing as shown before. And the reason why I'm using 8x8 and not a 4x4 or any other size is that 2x2 was too small. 4x4 was okay, but it was not much definition. and 8x8 wasn't too dense, but also had enough definition that you could still read, look at the image and see and know what's being drawn. And that's about it.